In this lesson, we're going to look at how we can solve a system of equations with 3 variables. But first, we want to look at how we can solve a system with 2 variables to kind of remind ourselves of systems of equations. So in these problems, the first problem we want to solve the system by using substitution. So when we use substitution, we're going to substitute in a expression for a variable, and we'll use substitution when it's evident that there's a variable that's already isolated. So for instance, in this first example, the y is already isolated, so we know that y is equal to negative 2x plus 6, so I can take negative 2x plus 6 and plug it into the y in the other equation. So we'll have negative 8x plus y, and y is now negative 2x plus 6, and that's going to be equal to negative 4. Okay, so if I just combine like terms here, I can combine the negative 8x and the negative 2x, so I have negative 10x plus 6 equals negative 4. I'm going to subtract the 6, and I'm going to get that negative 10x is equal to negative 10. If I divide both sides by negative 10, I'll end up with x equals 1. In order to solve a system, we have to find the point of intersection, so we want to make sure that we're solving for the x and the y coordinate. So we found x. Now what we have to do is plug in 1 for x in either of the two equations. So I'm going to just plug it into the first equation because it's already isolated the y. So we're going to say that y is equal to negative 2 times 1 plus 6. So y is equal to negative 2 plus 6. So y is equal to 4. And when we give our answer, we want to make sure that we give our answer as an ordered pair. So we'll do x comma y. So our answer here is going to be 1 comma 4. Okay, another type of way to solve a system of equations is to use elimination. So elimination is when we want to eliminate one of the variables. Now in this example, we could solve for y to get y by itself and use substitution, but we want to get used to using elimination. When you're using elimination, you want to make sure that whatever variable you're eliminating, that the coefficient of that variable is the same and the signs are opposite. So when we look at these examples, we have the x's have a 2 and a 5, so they're not the same number, and they're not the same sign. If we look at the y's, the coefficients are both 1, so it's the same number, but they're not the same sign. So I would focus on trying to eliminate the y's. So we want to make sure that we have the same number and opposite signs. So we have the same number in front, but we don't have the same sign. So what I'm going to do is multiply one of these equations by negative 1 in order to get the sign to be opposite. So you can multiply any of these two equations. So I'm going to multiply the first equation by negative 1. So this is going to become negative 2x minus y equals negative 12. So we're just distributing that negative 1 to all 3 pieces of this equation. The second equation, I'm not going to do anything to that, so I'm just going to leave it as 5x plus y equals 33. Okay, once I've done this, I can see now that the y's, they have the same number in front, which is 1, and they have opposite signs. Once I have that, I can go ahead and just add this straight down. So negative 2x plus 5x is going to give me 3x. The negative y and the positive y, they're going to cancel out, so they're going to be eliminated. And then, we're going to have negative 12 plus 33, and that's going to give us 21. So then I can divide by 3, and I end up with x is equal to 7. So similar to the other problem, we want to make sure that we solve for the y as well, so we have a point. So once we know what x is, we can plug x into either of these two equations. So I'm just going to use the top equation. So I'm going to have 2 times x, which is 7, plus y equals 12. So we get 14 plus y equals 12. I'm going to subtract 14, and I'm going to get that y is equal to negative 2. Okay, so again, we have an x and we have a y. So to give our answer, we want to make sure that we write it as an ordered pair and always write it in alphabetical order. So x comma y, so 7 comma negative 2. And that would be our answer for that. So before we get into crazy systems of 3 variables, we're going to just look at kind of an introduction example. So here we have three different scales. Okay, and we can see the scales are even because they're flat. So if I wanted to write a system of equations for the weight of each box, this first one, we can see that 2a is going to be equal to b. In the second one, we can see that c is equal to 3a. And in this last one, we can see that b plus c is going to equal 10. Okay, since we know that b is equal to 2a, we can substitute the 2a in for b. So if I look at this equation, the b plus c, b is now going to become 2a. I know that c is equal to 3a, so this c is going to become 3a, and then that's equal to 10. So when I add these together, I get 5a is equal to 10. When I divide by 5, I will get that a is equal to 2. Since we know a is equal to 2, we can plug that into both equations to solve for b and c. So 2 times 2 is going to equal b, so b will be equal to 4. And c is going to equal 3 times 2, because a is 2, so c is going to equal 6. So we were able to create three different equations using the three variables and solve for those three variables. Okay, so just to visualize what a system of three equations is, when we have a system of two equations, we're dealing with lines. So when we have something like x plus y equals 5, I'm making this up, and x plus 3y equals 10, something like this, we know that if I were to graph these, they're y equals mx plus b lines. So if I graph them, I really have three options. The lines could either cross where I have one point of intersection, which would be my solution. The lines could be parallel, where they never cross, in which case there'd be no solution. Or the line could be the same exact line, where they have every single point in common. So the line would be like on top of the other line. When we have three variables, we're adding a third variable into this. So now instead of dealing with lines, we're going to be dealing with planes. And you can see the three examples here. So when the three planes intersect at a particular point, that means that it has one solution. If the three planes are intersecting, but not at the same point, or they're just not intersecting at all, then there's no solution. And if all three planes are intersecting on the same line, then they have an infinite number of solutions. So for this one, the infinite number, you can think of it as like a book, and all of the planes are pages of a book, and the line is like the spine of the book. So they all have that one in common. So this is just visualizing what we're doing. So let's look at one example that's a little bit easy to start off with. So here we have three variables, x, y, and z, and we have three equations. Now this one's a little bit easy because they already gave us one of the variables. They told us that z is equal to 2. So since we know z is equal to 2, we can use substitution and substitute in 2 for z. So I'm going to look at the second equation, and I'm going to plug in the 2 instead of the z. So when I solve this, y plus 4 is equal to 0. I'm going to subtract 4, and I will get that y is equal to negative 4. So now that I have z and I have y, I can go to that first equation and I can plug in the z and the y and solve for x. So x plus 2 times y, and y is negative 4, plus 3 times z, and z is 2, equals 6. So I'll get x minus 8 plus 6 equals 6. If I combine like terms, I'm going to get x minus 2 equals 6, and then I can add 2 to both sides, and I'll get that x is equal to 8. So I have my x, I have my y, and I have my z. So when I go to write my answer, it's going to be written as an ordered triple. So again, just put it in alphabetical order. So x is going to go first, so we have 8, then y, so negative 4, and then z, which is 2. And this would be my solution to this system of three variables.